Hey everyone, welcome back to Active Class, your digital partner for learning. Today, we are diving into something super important in algebra, the laws of indices. These laws are the secret behind working with exponents effortlessly. So, if you have ever wondered how powers work or why calculators give a strange result for negative exponents, stick around. Let's crack the code. First things first, what are indices? Well, indices, also called exponents, tell us how many times a number is multiplied by itself. For example, in 2 power 3, we call this 3 index or exponent. It means we multiply 2 3 times, which is 8. In general, if we write a power n, it means a is multiplied by itself n times. Now, let's break down the most important rules of indices. First one is the product law of indices or the multiplication law. Let's see. Suppose we are given the same basis 2 and different exponents or different powers, which are 3 and 2, then if we multiply them, we simply add the powers. Let's see. 2 power 3 times 2 power 2 means we multiply 2 3 times and another 2 2 times. We get 5 2s, that means 2 power 5s, which gives us 32. See, we had got 2 power 3 and 2 power 2, and if we multiply it following the general rule of indices, then we got 2 power 5. Means if we add these two powers, we'll get power 5, right? We have written single base, but we added the power. Using the meaning of exponents, if we have got a power m, then we need to multiply a m times. And if we have got a power n, then we need to multiply a n times. Multiplying both gives a total of m plus n times. Like before, we multiplied 2 power 3 times 2 power 2, which gave 2 power 3 plus 2 means 2 power 5. Following the same process, if we multiply a power m and a power n, then power becomes m plus n. So, a power m times n equals to a power m plus n. Means, if we are multiplying the same bases with different powers, we simply add the powers. This is the multiplication law or the product law of indices. What happens when dividing the powers with the same base? Let's see. We are going to divide 5 power 4 by 5 power 2. The bases are same 5, the powers are different, and there is division. So let's try to divide. 5 power 4 means we need to multiply 5 4 times. And 5 power 2 means we multiply 5 2 times. Let's cancel the like factors. So if we cancel the like factors from numerator and denominator, then there remains only 2 5s. That means 5 times 5, which is 5 power 2. See? This 5 power 2 can be obtained if we subtract this 2 from 4. 4 minus 2 is 2. Means, in case of division, we simply subtract the exponents. Using the meaning of exponent, a power m means we have to multiply a m times. A power n means we have to multiply a n times. As we have done before, 5 power 4 divided by 5 power 2 is simply equal to 5 power 4 minus 2. That means power gets subtracted. So if we cancel the factors, then we will get a power m divided by a power n. Then this is equals to a power m minus n. We simply subtract the power. But make sure that there are same bases and division symbol in between. What happens when you raise a power to another power? Let's see an example. You already have power 2 of the base 3, and again another power 3 is raised here. So what happens in this case? If you follow the general meaning of indices, then this means you need to multiply 3 square 3 times. Now we have got same basis 3 and multiplication in between, means we can use the product law of indices. So you simply can add the powers over here. 2 plus 2 plus 2, which is 3 power 6. This 6 can be obtained by simply multiplying these 2 and 3 in the power, right? So instead of doing these long process, you can simply multiply the powers and write 3 to the power 6. So if you raise a power to another power, multiply the exponents. Let's see the general law. Using the meaning of exponents, a power m whole power n means you need to multiply a power m n times. Each term in a power m whole power n is repeated n times, so we multiply the exponents. Therefore, a power m whole power n means we simply multiply the exponent, means a power m times n. The fourth law is the law of zero index, means what happens if we got 0 in the power? Let's see through an example. Suppose we have got 3 power 3 divided by 3 power 3, means we have got same basis and same power and we are dividing. Then if we use the general meaning of indices, we just multiply 3 times in the numerator and denominator, and we cancel out the common factors from numerator and denominator. Here all the factors got cancelled, means we got 1 as the quotient. If we use the division rule of indices, then 3 power 3 divided by 3 power 3 means we simply subtract the power. So 3 minus 3 is 3 power 0. Here, this 3 power 0 and 1, these answers are obtained by simplifying the same expression. So we can write 3 power 0 is equals to 1. Means if we get something power 0, then we'll get the value 1. This is the law of zero index. The fifth law is law of negative index. What happens if we got the negative power? Let's again explore it through an example. Using quotient law of indices, means division law of indices. As for division law of indices, x power 3 divided by x power 5, it means we simply subtract the power, right? So x power 3 minus 5, which is x power 2. If we use the general meaning of exponent, then x power 3 divided by x power 5 means divide x 3 times in the numerator and x 5 times in the denominator. Then if you cancel the same factors from numerator and denominator, what happens? Let's see. So 3 factors got cancelled, right? So in the numerator, we are left with 1, and in the denominator, we are left with x times x, which is x squared. See? From the quotient law or division law, we got x power minus 2. From the general meaning of exponent, we got 1 by x squared. These two things are obtained from the same expression. Therefore, we can say that x power minus 2 is 1 by x squared. Means if you have got negative power, we simply can reciprocal it. Like this x power minus 2 has 1 in the denominator, right? So if we reciprocal, 1 goes to the numerator and x power 2 goes to the denominator, and power becomes plus 2. Following the same rule, if we got a to the power minus m, then to make it plus m, we have to write a to the power 1 by a to the power m. Okay? And if we have got a 1 by a to the power minus m, then it becomes a to the power plus m. So this is the law of negative index. If we have got negative index, this is how we make the index positive. The last law is a root law of indices or fractional exponent rule. What happens if we got fraction in the exponent? Let's again explore through an example. If you have got 8 power 2 by 3, then 8 is 2 power 3, right? So here, which law can we use? We raise the power of power, isn't it? Means we simply multiply the power. So 2 power 3 times 2 by 3, right? Here, this 3 and 3 can be cancelled out. So you got 2 power 2, which is 4. Let's think the other way around. Suppose you've got cube root 8 squared. Then let's simplify. Cube root 8 square means 8 square means 8 times 8. Cube root remains same. Now 8 is 2 power 3. This 8 is also 2 power 3. You know, if you have got cube under the cube root, then you simply take this out of the root. So this 2 and 2 will be out of the root. So 2 times 2 is 4. This indicates that when the index is in fraction, the denominator represents the root or order of the radical. Look at here, please. So index here was in the fraction, right? 2 by 3. The base is same here, isn't it? And if you simplify, you get 4. So here in the second case, the question is same. But what happened? This 3 came to the order of root, which we call radical, okay? And this 2 is the power of base. If you have got 64 power, let's say 3 by 4, then the denominator of 4 of the exponent goes to the order of the root. So this 3 goes to the power of 64. This is the root law. Like if you have got a power m by n, see, n is the denominator of the fraction, so that n will be order of the root and m will be power under the root. This is the root law of indices. All right, now it's time to test your knowledge with a quick challenge. I will give you an indices question and you have 5 seconds to shout out the answer before I reveal it. Ready? Let's go. First question. What is 5 to the power 6 times 5 to the power 2? Correct answer is 5 to the power 8. Second question. What is 5 to the power 6 divided by 5 to the power 2? Correct answer is 5 to the power 4. Third question. What is 5 to the power 6 raised to the power 2? Correct answer is 5 to the power 12. Fourth question. What is 5 to the power 0? The correct answer is 1. Fifth question. What is 5 raised to the power minus 3? The correct answer is 1 by 5 to the power 3. And the last question is, what is 25 raised to the power 1 by 2? The correct answer is 5. Great job, everyone. How many did you get right? Let me know in the comments below. If you got all correct, you are an exponent master. If you missed a few, no worries. Just rewind and practice again. Let's sum up the video. We discussed 6 laws with the examples and we try to verify the general formulae. The first law was multiplication law. The second one was division law. The third, we did power law. Afterwards, law of zero index. Then law of negative index. Finally, fractional exponent law. If you found this video helpful, don't forget to like, share and subscribe for more fun math lessons. Hit the notification bell so you never miss out our exciting learning adventure. Thanks for watching and remember, math is all about practice. See you in the next video.